To the second part of the Git talk. We're just gonna take a moment to remember or to remind ourselves of what we saw in part one. We looked at some theory. We looked at the VCS history generations, differences between them. We looked at how Git is structured, what are a few of the internal stuff that Git handles, how to commit, how to modify a file, how to modify the commit itself. We briefly looked at the basic branching model. We also looked at remotes briefly, and that's pretty much it. Today, the focus will be on collaboration, so team collaboration. First, we're going to take a moment to describe our standard 3FS workflow. The thing is that we have built this on top of the best practices that we gathered over the years. So ways of working has been evolving ever since the beginning, and the way it is right now, it will probably change in the future as well. So it's live, it's kicking, it's not set in stone. The thing is that if you're working on one project and move to the other, or just talk with team members from other projects, you're going to see that there are differences in the ways of working, but the 3FS standard is just a guideline for the basic foundation of the work. As you can see here on the slides, we strive to have the latest stable code in mainline, which is usually master branch. So I will probably mention mainline quite often in today's talk. So keep in mind that usually that's master branch. In some cases it can be developed or some other, depends on the team. The most important thing is that when you do your work, be it a bug fix or a feature or some support or whatever the change is, that's usually done in a topic branch. We can call it feature branch, we can call it bug fix branch. The agreement here is that we refer to it as a topic branch. What else? When the work is completed, it goes through review. More on that in different talks. But basically, once you get all the approvals, you merge the code back to the main line, you push it, and that's pretty much it. Your work is done. The main focus of today's talk will be two tasks that Alice and Bob are going to need to work on. So the boss or the manager or the client asked our team of two to complete two tasks. So one is just basically update the documentation of the repository that we worked on in part one, and the second one is it's a slightly bigger task. So the application itself, once run, needs to output a next to the day and time. So basically, if it's around before noon, it's good morning, and so on. We're going to see details later on. So Alice and Bob, they flip a coin. Alice gets to work on the first task. She will update README documentation. Documentation about the build information, and Bob will add the greetings. So this is our GitLab. There's one basic task there. It's just saying, hey, please update the documentation. And also, if there are some tools and steps required that we missed, just add them freely as you wish. Alice, first thing she does is assigns herself to the issue so that the rest of the team knows she's the one that will deliver this task. She goes to her terminal, checks out a branch called improve documentation from origin master. Git informs her, yeah, this is the branch. It's tracking master branch from the remote called origin. She checks the status. She gets the same confirmation back. The next step she does is she opens her text editor, writes the instructions. It's a very basic set of instructions with the requirements that you need as a developer to have the application running, and also how to actually run the application. It's in Markdown format. She adds the change with git add p, if you remember from talk 1. So from talk part 1, it's basically just adding patches of the changes to the staging area. Today we were probably going to skip a few steps here. If it's too confusing, just please stop me and I'll explain a bit more. But I don't want to spend too much time showing every single step. She checks the status. She sees that the file readme is now modified and it's in the staging area waiting to be committed. She commits it, writes the message, also references issue number 1 from GitLab with the keyword closes. Once this change is merged to mainline, GitLab will automatically close the issue. This is the commit, so checksum or the commit ID is 64AA2E3. And while she was working on this, she also noticed something. The code, while it's very, very simple, it's also a bit problematic to maintain down the road. So what she does is she opens the editor again, reformats the code. If you remember from part 1, code was basically just one line, nothing else. But the more you add, the more you complicate things, or the more logic you add, it's going to be a bit tricky to maintain, to see the differences and so on. For example, if you change just, I don't know, the first parameter, so instead of the weekday, you input something else, maybe a translation of that, Git will just note this line as a difference. Otherwise, it would always be the entire file, or at least a few lines here. So it's not much, but it's a small change basically. She again uses git add -p. She adds the entire patch and commits it with the short version, so with the shortcut. Again, please do not use this, but we're going to see why she did that in just a moment. So the next thing she realizes is, hey, so right now we're just going to run this code with go run main.go. But what if later on we need to add some dependencies? What if we change how the application is built? What if we need to add some flags to go run? So what she does is she adds a makefile. So this here pretty much is a standard 3fs makefile that we start with. There are a few targets missing, but mostly it's just the help that's really important. So this help, what it does is when you invoke make help, it will list all the targets provided by that makefile together with a description, which is basically just a comment here. So if you run make help here, it will display build, run, and help with text next to it. So you never actually have to go into the makefile and figure out what's there. Here, what she does is, instead of just running the application, she also introduces another step called build. Here in this step, I'm not sure if you can see that very well, but it says go build main.go, and the output will be in the bin directory, and the executable will be hello. If you do a make run, it will just run this previously compiled executable. So this way, if you later on change anything in regards to how to run or to build the application, it will still be the same set of commands that you as a developer need to run. So it's really nice for sharing purposes between team members. She continues with testing it out. So make build, this is the command that's produced, and make run, hey, this is what it does. It will actually say hello, it is Thursday, and the time is 11 something. Next thing she does is she modifies the documentation, so the README file, instead of having just two dependencies, there's now the third one, GNU make. Instead of doing go run main.go, she writes a bit more extended documentation on how to actually do that. Next thing she does is, before committing, she does a git status. Now this is a bit interesting right now, because she modified the README file and she added the make file. So this commit actually needs to include README and the make file, but there's also a bin directory here. The problem here is that this should not be part of repository, part of Git. The reason being is that that's an artifact. When compiled, it's going to be different. So every single time you're going to run it, it's going to change. And if you commit that, and if someone from your team fetches the changes and tries to merge the changes to his local or her local repository, there's going to be a conflict. And resolving binary conflicts is something that you really do not want to be left with. Luckily for us, Git knows a command, or there's a functionality in Git called ignore. So a git ignore. What we can do is we can open a file called .gitignore, and in this file, what we can do is simply add bin directory. Few important things to notice here is the first leading /. This means that the Git will ignore bin directory or anything starting with bin from the root of the project. If you omit this leading /, it will actually ignore every single file or folder called bin. So if you ever do something and some of your files disappear, it's usually because they are not listed from the root directory. The trailing /, this one is important, so that we instruct Git that please Git ignore just the folders. If you omit it, it will ignore the files as well, because to Git, if it's a folder or if it's a file, Git doesn't care. It's the same thing. Git ignore is really powerful, especially with some patterns that you can apply. Please look into this whenever you need it, but for now, this is all that matters. When Alice does git status, she can see, yeah, the file readme is still modified, there's makefile, there's .gitignore as a new file, but there's no bin directory listed anymore. And if she does a directory list in her shell, you can see that the bin folder is still here. So the next thing she does is she commits all the changes. She, of course, adds them and then commits them. There's a new commit. So she's now ready to actually push the changes to a remote branch. But just before pushing those changes, she thinks to herself, wait, I made 3 commits. Those 3 commits are basically just update build instructions, update documentation, and improve code readability. So the thing is, improved code readability does not belong to this branch because it's a completely different set of changes. However, on the other side, update build instructions and update documentation are part of this change. The only thing is that there's really no need to have 2 different commits here. So what Alice does is she says, okay, I'm going to remove the second commit from this branch and we'll merge squash first and the third commit together. So to do this, there's a tool called rebase in Git. Here, few important things to notice. So -i, this is a short flag for interactive, meaning that Git will ask us what to do. Head is just our current location, and with tilde and the number, we actually inform Git to say, hey, start from our current latest commit, and then take 3 commits back, and use those 3 commits to actually do something with them. If you want, you can also specify exactly the commit IDs, but this works just as well. Remember, for Git, everything you just referenced. So when you do git rebase, there's going to be, again, a text editor shown with all 3 commits there, and quite long list of possibilities that you can do with the rebase. Right now, what she needs to do is she needs to comment out the second commit, right? Because we will not need this one in the branch. But just before she completely removes it, she takes a mental note saying, okay, I need to remember this commit. It's 6D703 because I'm going to need this commit to bring it back to life later on. Next step, she just removes that line. It's the same thing if you remove it or put a comment in front of it, so a hash. Because rebase at this stage, we just take everything that's not commented out or not there. Plus, it's also a lot easier if you have both of them here. So the next thing is she knows she has to merge those 2 changes together. So there are a few ways of doing that. With rebase, it's very easily done with squash. So here, instead of pick, you change it to squash or simply to S. And in the next step, when you exit the editor, Git will open a new editor saying, okay, we are now at step 2 of our interactive rebase. This is what you want to squash. So it's commit 1, commit 2. This is the commit message that you inputted for the first commit, and this is for the second commit. So what do you want for this new commit to actually say? So what would be the commit message? What you can do is completely remove everything, write a new message. You can leave it as this and then later on amend that commit message. Or you can update as Alice did here. So commented out the second one and just fix the first line saying, okay, update build procedure. Next thing, when you exit the editor, Git will show you quite a bit of information about what was done. Here we can see some statistics. On its own, they're not very useful unless you are trying to see what exactly was there. But what you can do is just check for the log, and especially check for the differences between your local branch, as Alice did here. So what is the difference between origin master with improved documentation here? If you are already working in a branch that's tracking a remote branch, so here would be origin improved documentation, then just compare it with that. But here, since it's still just a local branch, she checks the differences in commits between origin master and improved documentation. So now she's ready, she knows what the change is. She does git push -u origin improved documentation, which will create improved documentation branch in the remote called origin, and it will also set the tracking of this local improved documentation with the remote one. When you do that, you get a familiar output as we have seen in part 1. Nice thing about GitLab is that we'll give you this URL saying, hey, this is a new branch. Do you want to create a merge request for this? And of course, she goes, yeah, why not? She can also click on this URL here. She goes back to GitLab, the web UI. It's also really nice because GitLab actually takes the commit message from that commit, and the first line is actually a title of this merge request. So the next thing she does is she looks, okay, yeah, there was one commit, it's update build procedure. She can also check the changes if the code is really as it should be. She simply submits this merge request, and now she just needs to wait for someone from the team to go in and approve those changes. Soon after the changes are approved by Bob, she goes back to the terminal, checks out the master branch, then checks what will be merged to master branch from her improved documentation branch. She does a very simple git merge because there's nothing in master yet. Checks the status, yeah, so it's one commit ahead of the origin master. Pushes the changes, and then the only thing that needs to be done is, hopefully you can see anything here, she looks at all the branches that are there locally, and she just simply removes the improved branch, the improved documentation branch, so her local version, and she also removes the remote improved documentation branch. So a really nice recommendation is keep your repositories clean as much as possible, because if you do not remove your local branches and especially your remote branches, then everyone will just get everything, and it's really hard to see what's the latest work, basically. Okay, so she removed the branches. There's nothing else left aside from the master branch and the remote master branch. So a few things to remember here. If you're doing interactive rebase, use either a reference, so between two references, or simply use head and say, okay, I want to do the last 3 commits or 5 commits. to delete a remote branch. This is the syntax. It's a bit weird, but it does the job. Yes?
So since in this interactive rebase you also have an option like D, which is a drop commit. Why didn't you use it? Is it a difference between using a D and just removing a line, or is there a special thing why didn't you use it?
So the question is, in Git rebase, there's an option to actually say drop commit. So instead of removing it, you put a D or a drop in front of the commit ID. So the same as we saw with Squash. It's basically the same thing. The reason I do not use drop is more or less just a habit, because it makes life a lot easier for me because I can see everything that's there. If I see something with a D, I'm going to have a bit of a problems understanding right away what happened, because I'm used to doing rebases on a lot of commits. So if you have 20 commits and you just need to squash, rearrange the order, fix up some commits, and you know that you're just going to remove 5 commits from there and you're left with 15 commits, it's a lot easier to see than 20. It's just that. So that's basically it. Just my habit. But it's the same thing. Yeah. Cool. Okay, so now remember that there's one commit that Alice needs to bring into the repository back. The thing is just that she gets this really urgent call and she needs to run to a meeting, so she's going to do that a bit later. But now Bob actually started working on his task. As we can see, it should be good morning after midnight, it should be good afternoon, and good evening after 7 in the evening. So that's his task. So what he does is, he remembers that he reviewed a change that Alice made. So the first thing he does is he fetches the changes. And you can see that there is a new commit, at least one new commit that was made. Next, what he does is he checks the status. He sees, okay, yeah, my branch is 1 commit behind. And the next thing he does is he checks out a new branch at origin, right? So Bob made 2 mistakes here. The first one is add origin, it should be called add greeting, right? But because he mixed origin, remote, whatever the commands were, he just named his local branch add origin. So nothing wrong with that. He can rename that later. A bit bigger mistake that he made is he fetched the changes from the remote, but he didn't merge them to local master. So his local master is still 1 commit behind. So again, it's not a problem. There's a spoiler alert. He's going to fix that later on, but he will have some problems because of that. As you can see here, because he checked out a branch and didn't specify what is the branch's starting point, it's actually set to the local master, which is 1 commit behind. So the next thing he does is he modifies the code. He realizes that before actually doing all the greetings, he needs to introduce a new variable called greeting here, and by default it's called hello. Next thing is he adds the code again with -p and commits it. He commits it using refs keyword, which is just a way of instructing GitLab to say, hey, please reference this commit in the issue view. He commits it, and then he does the same thing for all 3 other commits. So good morning, good afternoon, and good evening. So we will skip this, but what he actually did is he made 4 commits with every single commit being a change. He now realizes that he has been working in the wrong branch. So no need to panic, you can simply just rename it, and you can rename a branch in Git by moving it to a new name. So now it's going to be called add greeting, which is a correct name. And he verifies it and sees that there's only the master and the add greeting branch, so that's okay. So now he's ready to actually push his local changes to a remote branch called add greeting. The push goes through. He also gets this URL to create the merge request. He opens the merge request. There's one difference here between his and Alex's push. Since Alice has just one commit, GitLab will pre-populate the description area. Whereas here, since he has 4 commits, GitLab will not do anything, and it's up to you to actually write the description if you want to, but it's not necessary. So the required field is add greeting. He scrolls down and he sees his 4 commits, so everything is here. He also goes to the tab on the right, changes, and he can see all the code he wrote. Right? So if you remember from earlier, that's one commit, second, and the third one. Right? He opens the merge request, and he is now rushed to a meeting again. So one command to remember is to rename a branch, just move it with -m. Now Alice is back from her meeting, and she now opens a new ticket for herself, or an issue for herself, called Improve Code Readability. So the thing is, she wants to reference an issue for every single commit. This is what most of us are used to doing. So what she does is she fetches the changes. There are some changes here, as you can see. So it's the Bob's changes from earlier when he pushed all his code for the add greeting change. But now one thing that she realizes is she was stuck in a meeting for some time. She only took the mental note of that commit ID, but she has no idea what that commit ID is right now. So the commit with the code readability changes, right? So she knows it's 607, 670, something like that, but she can't really remember. What can she do? She can either write the change again, which in this case would make sense because it's just a small change. But luckily for her, there's a tool in Git called reference log, or reflog in short, for short. So by doing git reflog, you get every single thing Alice did prior to her removing that branch or commit. Git reference log keeps information about merges, rebases, checkouts, commits, resets, basically everything that you do with Git, it's logged here. You can either revert back to one of the heads or just use one of the commit IDs and it will do that. She looks around and she finds her commit. So it's this one. So it was 6D70 something, right? One really important note about reference log. If you clone or initialize a new repository, the reference log is empty, basically. So even if you do something like this in your local repository and then you clone it somewhere else, it's gone. If your .git directory is corrupted, it's gone. Right? So this works just locally as long as you have it. If you remove it completely, clone it again from the remote central server, it's gone. Okay? But as long as you have it, everything is there. If that makes sense.
So if you copy the .git directory somewhere else, will it still work?
Yes. So the question is, if you copy .git directory somewhere else, will it work? Yes. If you clone from, if you take your local repository and then you clone it somewhere else, it's gone. But it's still in that original one. But if you just move .git directory, yeah, you get it with yourself. Okay, so now she has the commit ID that she needs to put into a new branch. There are several ways of doing that again, but she decides to go with a thing called cherry picking. So cherry picking, as the name suggests, is basically just picking up cherries, so to say. So you just pick it one by one. And to do that, what she does is she creates a new branch called Improve Code from Origin Master. So it's tracking Origin Master. And the next thing she does is she cherry picks this commit ID. Cherry pick can take more than one argument here, so more than one ID. But since it's just a small change in one commit, she does it like that. What happens next is Git takes this change and reapplies it, meaning that it will take the change and recommit it again into this branch. As you can see here, the new commit ID is 873 something something, right? So from part 1, Git is all about integrity. So whatever you do, it will change the ID because the checksum changes, but it will be there. It's the same thing more or less, except that the object internally in Git is not. She checks the latest log information, and she can see, yeah, this is mine, this is the comment I wrote, and this is a change. Yay, everything is there. And if you look at reflog at this point, we can see that the original commit is still there, right? It's still inside Git. But there's also the new commit here. And you can also see that it says cherry pick with the commit 8730 that we saw earlier when the commit was applied. So next thing what she does is she pushes the code, opens merge request for review. Bob reviews the code, says, yay, this is fine. She merges this back, and then she goes on reviewing Bob's merge requests. So a few things to remember here. Reflog, please keep this one close to yourself. If you have any problems with commits, with branches, if you mess everything up, it's still in reflog, as long as it's committed. If you remove the file before adding it to either index or a repository, you cannot get it back, maybe from your backups, but that's about it. So commit. Even if it's a temporary commit, just commit it. The next thing is cherry pick. If you need to move a single commit or few commits from one place to the other and merging or rebasing takes too much effort, just use cherry pick. Okay, now Bob gets few comments. One is that one part of the code is completely useless, then all these if statements are completely useless, there should be a switch. And also, why use 4 commits if it's just one single change? It makes no sense. So he's asked to squash them. So what he does is, he goes back, fixes the code. This is what the code looks like now. This is the difference. So it's switched instead of a bunch of conditions. Fortunately, cannot see that because of the sun. He adds the code, he commits the code, and when he looks at his local log, he can see that, hey, there's just one commit called TMP will be squashed. Oh, yeah, okay, sorry. So what he did was he basically made a new commit, and now he needs to squash all these 5 commits now together. So what he did first was he modified the code based on the comments he received in the code review step. And the next thing is the last comment was basically saying, please squash everything into one commit. There is no need for having 5 or 4 of them. Again, few ways of doing this here. One is doing a git reset soft, but we're going to look at a rebase because it's more fun. So he does git rebase on the last 5 commits. He's greeted with pretty much the same view as Alice was earlier. But now he looks at what options he has, and he chooses to reword his first commit, because it's just saying, hey, use greeting variable. It's not useless. I mean, it's completely useless. And then he, instead of doing squash, he just says, okay, take the next commit, fix it up, and forget fix up means that it will take the change, but discard the commit message completely. So if you remember from earlier, Alice was shown, in the text editor, she was shown those 2 commit messages, and she had to comment out one and just fix the other. Here, with fix up, you just basically say, hey, I don't care about the commit message, I care about the change itself. So it's basically the same thing. The only thing is that it's a lot faster if you do a fix up, because there's no need to comment out or to remove messages at that point. So the next thing is, when you close the editor, there's going to be another editor opened with the default, with the first commits message, so the one that we selected for a reward. And Bob here, what he does is he just fixes the commit message saying, okay, this is what the change is, and instead of referencing this issue, just close it. That's it. Git will rebase all those changes, and if we do a git log right now, we can see that there's just one commit, which is called show greeting, and it's one commit ahead of the master branch. Also, if he does git log on this last commit, he can see basically everything is there as it should be. So in ref log, if I reference it a little bit from earlier, in the ref log you can still see all those 5 commits together with this new commit, which was a rebase. So nothing is lost. If you did a rebase by accident, don't worry, it's still there. So now what he did was he checked for status, and he can see that his local add greeting branch has 1 commit, and the remote branch called add greeting has 4 commits. So for Git, this means that these 2 branches have diverged. So this is okay, right? What he does is he checks the differences between his local and his remote branch, and he can see the following. So there are 5 commits here, right? And if you examine the characters here, so the arrows pointing into which direction, you can see that this one is pointing to the right, which means it's our local branch called add greeting, and these 4 are pointing to the left, meaning it's this one, so the origin add greeting. So to show it a bit better, this is the one that's locally, and these are the ones that are in the remote branch. So what we need to do here is we need to sync or bring them to the same state to resolve the code review comments. What we do now, or what Bob does now, is he says, okay, yeah, I need to push those changes to the remote branch, but the thing is, when he does that, his push gets rejected. And the reason being is that they are not on the same state. So if you simply add few commits on top of what's there in the remote branch, it will work just fine. But if those branches diverge, you cannot simply push the changes. Instead, you need to do force push, so doing -- force, or just a simple -f. When you do that, Git will say, okay, yeah, you can do that, because you are sure that you're rewriting the remote branch history as well. This is your merge request that's already opened. You can go there and you can see what happened. When Bob does status, his branch is now up to date with the greeting. When he goes to the web UI, he can see that all these things have now been resolved. So this is now great. What happens next is Alice is back and she says, okay, yeah, your change is awesome. There's also one thing that I forgot to mention a bit earlier, but let me just go back. So here, GitLab is also instructing Bob that there are some merge conflicts, but he ignores that because he knows he checked out from master branch. His master branch is up to date, so there shouldn't be a problem, right? So it's probably GitLab doing something wonky. Now the thing is, now he goes back to his local repository, checks out master because he needs to merge the code. He now gets this saying, okay, you are 1 commit behind, and he remembers, oh yeah, right, I forgot to merge the changes, right? So he just fetched the changes earlier. He does that, nothing major happened, there's fast forward, so everything is okay. He checks the status, all right, so cool, my local master branch is in sync with the remote master branch. So the next thing he does is, as always, he just merges the changes from the add greeting topic branch. But now something weird happens, right? This never happened before. When he did a merge earlier, the merge just happened automatically. So now he's asked to do some sort of a message here. It turns out that this is a commit message for a commit called merge head commit, or is it merge commit? Merge commit, right? So Bob says, okay, yeah, maybe it's a new feature in Git, maybe there's something else. He plays along. Git now says, yay, merge is made using the recursive strategy. So it's not fast forward, right? So why is that? He looks at the master branch and sees that his local master branch is 2 commits ahead of the origin master. But that shouldn't be the case, because in his add greeting branch, there was just 1 commit that he successfully squashed together, right? From all those 5. So what he does is checks the log. Yeah, right, there's a new branch. There's a new commit called merge branch add greeting. So it's the one that Git asked us about the message earlier. So how come this happened, right? He checks the graph. If you pass the -- graph to log, it will actually display a graph version of his history. So what happened is there's a small kind of like branch here that shouldn't be, because we are always striving to get this linear branch, right? So also there are some asterisks here, some pipes here, some colors are different. So what the hell happened? He goes back, checks the log again. Sure, this is it. Then he remembers. The problem is that there are some things in his master branch that are not in the add greeting branch. The problem was that when he checked out that branch, if you remember from earlier, he didn't specify the starting point to be origin master, but it was his local master, which was 1 commit behind the remote master. So now he's left with few options. He can either create a new master branch from the origin master and then cherry pick that change in, but this means that he needs to force push everything again, and he will probably get into some other errors. So he does this. First thing he does is he performs a hard reset on the existing master branch, which will just basically say, okay, discard everything you have in your master branch and just set the tracking point to be at the tip or the head of the origin master branch. When he checks the log, he can actually see that his master branch is now in track with the origin master, if you can see it here. So it's the same thing. The next thing he does is check the status. It's up to date. He tries merging again, this time passing in the ff- only flag. So what this does is it instructs git merge saying, hey, please merge my changes, but only if it's possible to do that with a fast forward strategy. So when he does that, fatal, not possible to fast forward. So a pro tip here, if you are merging, always use this flag. It will save you quite a lot of time because there would be no need for you to either create a new branch or to reset your local branch. Right, so the next thing is he now checks the differences between the remote master and his local add greeting, and he spots this commit, right? So this is the one that he reviewed earlier. He fetched those changes, but never merged them to master branch. So the next thing is he again checks out his local add greeting branch, and now to bring the changes from the master branch, he does a git rebase. And the rebase is basically from origin master. He could also use master right now, but again, one of the pro tips, always use the remotes, because you never know, like in Bob's case earlier, even though he had a local master branch, it was behind the remote branch. Rebase happens without any problems. Everything is clean. He checks the log. Hey, it's super good. Compares the differences between his local branch with the remote branch. He sees there's just 1 commit here, which is okay, so it's his change. The next thing is, if he checks for status, he can see again that his local and the remote branch have diverged. And now he needs to force push those changes back. If he doesn't, then the merge request will not be automatically closed in GitLab. That's the only reason you need to do that here. So when he does that, Again, this works fine. Now he checks out the master branch. He merges the add greeting without the --ff only, so he hasn't really learned anything from his earlier mistake, but now it goes through. So everything is okay. The only thing he needs to do now is push the changes to master branch and he's done for the day, right? He gets a rejected push. Now why is that? Right? So Bob now gets a little bit frustrated. So he did everything okay, right? He checked the logs, he checked the diffs, he compared all the things, he made sure that his branch is up to date with the master branch, but still he gets his push rejected. So there are a few ways why this might happen. One is that simply you do no longer have permissions to actually push stuff, which is kind of weird. The second thing is that's really most of the times when this happens is because someone else from your team pushed something to master branch. So in this case, what you need to do is just fetch the changes and basically do a rebase again and merge them back in push, and hopefully no one will cut the line again. Or in this case, he simply didn't have the latest version. And this is exactly what happened. So he does a git fetch and he sees, oh wait, someone did cut my queue line, right? But the thing is now, when he does git status, he can see that there's one commit in the master branch that he doesn't have in his local master branch. He checks for the differences in commits, and now he can see that improved code readability is there, right? Now he remembers that he reviewed Alice's code but forgot to fetch the changes and work on top of those changes. And now he knows that probably there's going to be a conflict in the code. So he does, he basically, before merging or rebasing, what he does is he checks whether the patches can be applied. So this is something that's nice to know, but not really needed. So what we do here is we ask Git tell us, hey, what is the patch in the origin master, and put it to standard output, and then just pipe it to git apply and check. So what this will do is it will say, hey, you can merge your changes easily or you cannot. And in this case, he cannot, right? So there's a problem on the line 6 of the main.go file. Now he knows that he will need to resolve conflicts. The way to do that is you can just simply do a merge, and you will get an editor with, well, you will get into a conflict state, which you need to resolve. You can do a rebase, which will do the same thing. You can just reset your master branch in this case, or check out a new one if you want to, and then cherry pick your changes in there, or you manually fix the code if you want to. So there are many other ways of doing it. It really depends on the use case. It really depends how you feel, how much time you have, the complexity of the change, and so on. But here, what Bob does is he says, okay, I'm just simply gonna rebase my local master branch. And when he does that, he gets a git saying, hey, you have conflicts in your code. Please investigate, and please let me know when the conflicts are resolved so I can continue rebasing. Here you can actually say, okay, abort a rebase altogether and then try a different approach. You can say skip, so rebase will skip current change, but if he does that, what will happen is that his change will be gone. So he will need to reapply it later on. But here he really wants to resolve the conflict. Or you can say continue, and rebase will just say, okay, this is the current state, I'm just going to apply this patch and move on. So whenever you see some changes being fetched which have these weird characters in, indicating the conflicts, that's what usually happens. So you either don't resolve all of them or you simply continue. Bob checks the status and he gets the same message back, except that in this case you cannot really see it here, but there's the main.go, which says both modified. He opens the file, the code. Here what's really important to understand is you have these arrows pointing into one direction, arrows pointing into the second direction. So everything in between is in conflict state. What's separating this conflict is a set of equal signs, meaning that between the first arrows and the equal signs is the initial state. So this is basically the code that's currently in origin master. It's the code that Alice wrote. And following this is the code that Bob wrote. So it's ours. In this case, there's a head written here, the first line, meaning that this is the latest commit. But if this happens, if you have, let's say, 10 commits, and this happens in the third one, you will get the ID of that commit here. So you can actually go in and investigate what happened here. And at the bottom, you can see the message of the commit that you just wrote. So again, one of the things when it comes to properly formatting a Git message is always make sure that the first line is clearly indicating what the change is. Otherwise, if you have TMP here or VIP or will fix later, you have no idea what this is all about. Okay, so Bob, what he does is he removes the conflict. The thing is that he left his code and accidentally left Alice's code here as well. Because he's in a hurry, he didn't really pay attention to what the conflict was. He solved it, he saved the file, exits everything, and just says, okay, rebase, I'm ready, please continue. And the rebase says, hey, yeah, I need to know what the change was, so you didn't really do anything, you didn't resolve it. The way to resolve conflicts is not to just modify the files, but it also means that you need to instruct the rebase that you have done it. By the way, if you do it with cherry picking or merging, it's the same thing, right? You still need to do these steps. So Bob does git add main.go. You cannot use patch here. So that's one of the things. You either commit everything or you don't commit anything. So in this case, patch doesn't work. Now when he does git rebase continue, rebase says, okay, I'm applying this change. Cool, it works, conflict resolved. Bob does git status, everything is fine. Checks the log, there's just one commit. He checks the graph, yay, it's one linear tree, that's really nice. He checks the latest commit to see if the commit message is correct, if the changes are correct. So he says, yeah, these are my changes, yay, super good. But just before he actually pushes everything to master branch, he runs the code. And by running the code, he actually sees, okay, why is it saying hello? And why is it saying good afternoon right after that? He realizes almost immediately that, yeah, I didn't resolve the conflict correctly. So he's now really getting frustrated. He moves into the add greeting branch because he's fed up with master. Just in case, he fetches the changes again because he doesn't want to repeat the same process all over and over again. He checks the differences between the origin master and his add greeting local branch. The situation is the same. What he does now is, again, he does a git rebase origin master. He knows that there's going to be a conflict. The same thing happens again. He now modifies the code properly and also formats this line of code the same way that Alice did, so that none of the changes will actually be gone. Before even marking the file or the conflict as resolved, he tries to run running the code, and he can see, okay, now it's finally working as it should. He resolves the conflict, instructs rebase to continue, checks the graph, everything is okay. Checks the status, everything is okay. He force pushes again the changes to the remote add greeting branch. Again, this is strictly for GitLab to properly close the merge request. Now, the only thing he needs to do is move to the master branch. He sees this, okay, yeah, there's already one commit in master branch that's ahead. Okay, so I already did merge my changes. He's frustrated, keep in mind. He's also late for a really important date. So now what he does is he removes his local add greeting branch, again tries to run the application, still doesn't work. Why is that? Well, the reason is, can you see that? Okay. So the reason is that he removed the branch, but he didn't merge everything in, right? So the change that's in master is still from that wrongly resolved conflict from earlier. So now the problem is that even though he actually fixed the problem in his add greeting branch, it's no longer there, right? So what he does is first he hard resets origin master, so it doesn't contain that wrongly resolved conflict again. And now he needs to figure out how to get that commit back. There are a few ways of doing that, as always. First, he checks what this commit actually is, and he sees, yeah, this is exactly what I need to bring into the master branch. He can use reflog, if you remember from earlier, or he can create a new branch called add greeting from this commit, which he does. He then merges this branch into the master branch, and when he checks the log, everything is properly done, right? So here we saw a different way of doing things. So instead of either cherry picking from a reflog, what Bob does is he creates a new branch from this reference, and then merges this branch, and then he needs to remove the add greeting branch again. If you are wondering when to do cherry pick compared to this approach, if Bob in this case would do a cherry pick, he would need to force push the changes back to his remote branch, so another step involved. In this case, it would make sense to do it like that. Or to make it even faster, instead of creating a new branch, you can just instruct Git and say git merge this ID. If you remember from earlier, Git cares about references and IDs, not about names. So these nice names are for us humans only, not for Git. Git will still translate this. So he pushes to master, now everything is there. He checks the branches, he can see that he has just the remote branch which he removes. And that's it, he's done. There are a few things to remember here, so if you want to check the graph in your terminal, just use the graph parameter next to git log. If you're using GUI for this, it's even easier. If you want to reset to a certain state in Git, use reset hard. There's also soft. The difference is that hard will reset to this given commit or reference, whereas soft will just not reset directly to that commit, but it will take all the changes until that commit and just put them as a modified into the modified or untracked state, depending on what the changes were. So instead of doing amend or rebase, in some cases we have to squash. For example, in what Bob had to do earlier with squashing 5 commits, he could also do a reset soft for those 5 commits, and then just commit them again as a new change. Always use FF only if you're working here, because it will make your life easier if there's a problem with merging. And then some commands for rebase, so continuous skip and abort, which you already covered. So a few things that are also good to know about Git. There are things called hooks. Hooks are custom scripts that are executed on some pre-configured events that Git works on. They are used to help with certain tasks. So for example, verifying that your commit message is properly formatted. So if you're working on a project which requires every single commit to have a reference to let's say a Jira issue or GitLab issue or whatever the issue system is, you can do it with that, or you can instruct Git to actually run the tests before commit or after commit, or before pushing or after pushing the code, etc. So these hooks, they can be in any language that you want, as long as the script is executable. Usually it's some shell scripting language, or Ruby or Python or Perl, whatever, it's there. When you clone or when you initialize a new repository, there's already basically all the client-side scripts are already there as a sample. So they will not be executed unless you actually modify those scripts and make them executable. But you can already see which events are covered and a few examples on how to do this, this validation. Next thing that's really nice about Git is Git comes with support for aliases. So think of aliases as shortcuts. So before checking what those aliases are, they are stored in the Git's config files. If you remember from part 1, they can be in 3 places. Usually you would want to have your shortcuts or aliases done in the global config file. If you're using OMyZSH, there's a Git plugin that has an extended list of aliases already defined and some functions as well. You can check it. You can check everything out on this wiki page. And to configure those aliases, you can either do it manually in the file itself directly, or just use git config helper command. And basically what this command does here, it will set alias co to be checkout. So when you do git co, it will actually check out, and you don't have to write the whole word here. Few examples. This is what I'm usually working with. So DC is checking all the changes that are already staged. If you do git diff there, it will say nothing, but you have to do cached. So st instead of status, ci instead of commit, br instead of branch, etc. This is my favorite, probably the last one, because it will fetch from all remotes. It will prune everything that has been removed from the remote. So for example, if you remove a branch from your remote, and then the next team member will fetch, it will still be there listed, but if you put in the prune parameter, it will just remove everything that's not there anymore, and the progress, so you know what's going on. Otherwise, it's quiet. This one is a bit more complex, as you can see here, and I actually have an example of it. So if you do git log graph, here I'm using alias as well, so slog, which stands for short log. It's the same as git log -- one line -- graph. With git lg, it will actually display also when this was committed and who committed it. So just the name. You can put emails here as well if you want to. And if you do git lg -- help, it will say that lg is alias to this command. So if you are ever in doubt, just do it like that. You usually don't want to search through your config files. Another thing that Git comes shipped with is Git allows you to have custom commands. So it's very similar to aliases, except that in this case, it's actually an external command that you can execute. If you have any executable script or file in your path that's discoverable, and you name it git dash that name, you can then use it in Git as git name, and it will actually do something like that. So one of the examples, it's not really the best example, so it's not production ready, so to say. There's this file called git update, which, as you can see, what it does is it will check which branch we're currently on. It will fetch all the changes. Then it will check if this is not a master branch, so it means that we are in a topic branch. It will rebase those changes back from the remote branch. And then the last thing, it will just rebase everything from the master branch. So this is basically your day-to-day routine. When you're working on something, if there's more than one person working on a remote branch, or I mean on the same branch, this comes really handy. If you're the only one working on it, then this comes really handy. So basically, instead of doing, hey, git fetch everything, then check what differences are if you need to, and then rebase all the changes onto my topic branch, you can just do git update, so something like this, and it will actually output this. So this is what git commands are usually used for. I have seen many things like git standup, which will actually just give you all the commits that you worked on for the past 24 hours, which comes handy for Scrum workflows. Then for some advanced statistics or release processes or something like that. But most of the time you are good with aliases. Few more resources added from last time. So especially this on my ZSH wiki page for Git plugin if you're using it. There's also this ohshitgit.com, which has few nice examples. Some of them were covered today here as well. So if you are ever in a mess, just look it up. And again, ask your colleagues around yourself if you are stuck with something. That's it. Comments, questions? Jean. Cool. Anything? Okay. Thank you for your time.